Okay, now we're going to work on sketching the graph of a log or a natural log function that has been transformed. Well, the parent graph of a log is either ln of x or log of x, right? And on log of x, the base number is 10, and for the parent function, and for ln x, the base number is e. And the difference in the two graphs, this might be the graph of the log of x. The natural log is going to look similar. It just rises. Here, let me do that in a different color. ln, it rises more quickly because e is a smaller number than 10. E represents 2.718 and goes on infinitely. So at 2.718, we're up there at 1. But it takes the log with base 10 all the way till you get out to 10 before you're up there at 1. So that's the basic differences between natural log, log. Okay, so and I think in the example I probably sketched log. And the basic parent domain and range is, if you look at this graph for natural log, and since this is natural log, I really should have graphed it more like it should have been right there at 1. So since this is natural log, that's the natural log. This is log log right here. This is ln, the basic parent function. So notice for the domain, the x values get really, really close to 0, but then they head off to positive infinity. And now let's look at the range. The range is coming from negative infinity, and even though it's turning, it is still going up. So for the log graph, log or natural log, the range, it doesn't matter how it's been transformed, the range will be negative infinity to positive infinity all the time. But now we have a transformation. Remember what we said before when it was log of x or ln x, wherever that asymptote, whatever zeroes out the x, that's your first value. So for this graph, whatever zeroes out -1, which is 1, that means this asymptote, I'm going to move this out of the way, this asymptote gets moved over 1. So the dot that was normally at 1 also gets moved over 1. But this, subtract 4, means that we shift everything down 4. Well, an asymptote, you can shift it down all you want, but it's infinite. So you don't have to worry about shifting that down. And there is not a number being multiplied, a fraction or a decimal, so we don't have to do anything else. We just know that this graph, let's see, I was up there at once, we're going to move that over. So right about there, this graph is going to be doing this. But if you're not great at estimating, all you have to do is plug this into your calculator. So plug 1 into your calculator, you're going to get undefined, or calculator domain error, that's where the asymptote will be. Then you're going to plug 2, 3, 4, and 5. When you substitute 2 for x, well, the natural log or log, 2 subtract of 1, the natural log of 1 or log of 1, doesn't matter to the base, we're going to be at 0. 0 subtract 4 is -4. And then all of these others, so right here, we're when we're at 2, we're down at -4. And notice these values begin to rise. So this will be -3 point something, probably still -3 point something. This might be up to -2 point something, I'm not sure. But the point is, you just plug these values into your calculator. So you'd hit the ln button, it gives you a left parentheses, 3, and inside there that says subtract 1. Close the parentheses. If you don't do that, you'll get a wrong answer. Subtract 4, and whatever that value is, that's what value goes there. Then you do that again, but you plug in 4. You do that again, you plug in 5. And that's it. That's it for this one.